Picture this. A new male lion wanders into a pride he's just taken over after defeating the previous dominant male in a brutal fight. Within days, something happens that seems almost impossible to reconcile with anything we associate with animal parenting. He systematically kills every cub in the pride that isn't his own offspring. Meanwhile, nearby, an ancient human family watches this exact behavior unfold from a safe distance. And if they could talk to us today, they'd probably ask the same question running through your mind right now. Why would any animal do something so brutal to its own species' young? This isn't some rare, isolated glitch in nature's programming. It happens across countless species, for reasons that once you understand them, reveal something surprisingly logical hiding beneath the horror. So let's break down exactly why animals sometimes kill their own offspring, and what ancient humans likely observed, learned, and occasionally avoided repeating themselves. Let's start with the most well-documented example, since lion behavior gives us a clear entry point into this uncomfortable topic. When a new male takes over a pride, killing existing cubs isn't random cruelty or some kind of territorial rage. It's calculated reproductive strategy operating at a purely biological level. Female lions won't enter estrus and become receptive to mating again while they're still nursing cubs from a previous mate. By eliminating those cubs, the new male essentially resets the female's reproductive clock, allowing her to become fertile again much sooner and ultimately bear his own offspring instead. From a cold evolutionary standpoint, this behavior maximizes the new male's chances of passing along his own genetic material before he himself gets replaced by another challenger, since dominant male tenure in a pride rarely lasts more than a few years. This pattern, known among researchers as sexually selected infanticide, appears across numerous species beyond lions, including certain primates, rodents, and even some marine mammals. Male longoor monkeys, for example, display remarkably similar behavior when taking over a new troop, targeting infants fathered by previous dominant males. The underlying logic remains consistent throughout these different species. Genetic competition drives behavior that seems monstrous from a human emotional perspective, but makes brutal evolutionary sense from a pure reproductive math standpoint. Every animal is essentially running a biological program designed to maximize the spread of its own genes, and sometimes that program includes eliminating genetic competition in the most direct way imaginable. Now here's where things get even more complicated, because male-driven infanticide represents only one category among several distinct reasons animals kill their own offspring. Let's shift toward maternal infanticide, which operates under an entirely different set of pressures and logic. Female animals across numerous species sometimes kill their own offspring, and while this seems even more counterintuitive given the enormous biological investment involved in pregnancy and birth, the reasoning often centers around resource scarcity and survival triage. Consider a scenario involving limited food availability, harsh environmental conditions, or a mother facing serious health complications following birth. In many species, particularly those giving birth to multiple offspring simultaneously, mothers facing insufficient resources to successfully raise every single offspring will sometimes eliminate the weakest or most vulnerable among the litter. This brutal calculation actually increases overall reproductive success in a strange, roundabout way, rather than spreading limited resources too thin across every offspring, resulting in potentially all of them dying from malnutrition or neglect. Focusing available resources on the strongest, most viable offspring increases the odds that at least some genetic material successfully survives to adulthood and eventually reproduces itself. Pigs demonstrate this pattern with particular frequency, occasionally consuming weaker piglets within a litter, especially when environmental stress or inadequate food availability threatens the survival of the entire group. Rabbits show similar behavior patterns too, sometimes abandoning or actively eliminating offspring when environmental conditions suggest insufficient resources exist to successfully raise the entire litter. This isn't emotional cruelty in any sense comparable to human understanding. It represents a kind of ruthless biological accounting system, prioritizing overall genetic continuation over sentimental attachment to every individual offspring. Let's talk about something particularly fascinating regarding maternal stress and inexperience, since first-time mothers across numerous species show significantly higher rates of offspring mortality or outright infanticide compared to experienced mothers who have successfully raised previous litters. This pattern makes considerable sense once you consider just how physically and psychologically demanding successful parenting actually is, even within the animal kingdom. An inexperienced mother facing overwhelming stress, unfamiliar physical sensations following birth, or general confusion regarding proper caregiving behavior sometimes responds through abandonment, or, in more severe cases, active harm toward offspring. She simply isn't psychologically prepared to successfully raise. This particular pattern likely played a meaningful role in shaping how ancient human communities approached childbirth and early motherhood support. Unlike many animal species that leave new mothers to navigate parenthood entirely alone, ancient human communities developed extensive social support systems specifically surrounding pregnancy, birth, and early infant care. Experienced mothers, grandmothers, and other community members likely provided crucial guidance, physical assistance, and emotional support that helped new mothers successfully navigate the overwhelming demands of caring for a helpless human infant. This cooperative support system may have significantly reduced instances of maternal abandonment or harm compared to species where new mothers face parenthood in complete isolation. Now let's examine something worth exploring in more detail regarding cannibalism specifically, since this represents perhaps the most viscerally uncomfortable category within animal infanticide behavior. Certain species, including some fish, insects, and even occasionally mammals, will consume their own offspring under specific circumstances. And the reasoning behind this behavior varies considerably depending on species and environmental context. In some cases, particularly among fish species like certain cichlids, parents may consume eggs or fry that show signs of disease, genetic abnormality, or simply appear unlikely to survive to adulthood, essentially eliminating a poor genetic investment before committing further resources toward their care. In other species, cannibalism serves a more directly practical nutritional purpose during periods of extreme food scarcity. Rather than watching offspring slowly starve alongside the rest of the family group, some species will consume weaker offspring specifically to provide crucial nutrition that helps ensure survival of remaining, stronger offspring, or even the parent's own continued survival, which itself remains necessary for potentially raising future, more successful litters when conditions eventually improve. This represents an extreme but evolutionarily logical response to desperate environmental circumstances, prioritizing overall genetic legacy over sentimental preservation of every single offspring regardless of survival probability. Speaking of behavior that sounds made up but absolutely isn't, certain species of hamsters have earned a reputation among researchers for consuming their entire litter if they sense excessive human interference or stress during the earliest days after birth. This is apparently common enough in captivity that pet stores and breeders specifically warn new hamster owners against handling babies too early, essentially turning "don't touch the newborns" into one of the most universally repeated warnings in small pet ownership. It's a strange reminder that even creatures we consider adorable and harmless carry the exact same brutal evolutionary calculations running quietly beneath that fluffy exterior. Let's shift focus towards something particularly relevant for our ancient human perspective. How observing this behavior across the animal kingdom likely shaped ancient human understanding and decision-making regarding their own survival strategies. Ancient humans undoubtedly witnessed countless examples of animal infanticide throughout their daily existence, whether through direct observation during hunting expeditions or simply through general awareness of animal behavior patterns within their environment. This constant exposure to nature's often brutal reproductive logic likely influenced how ancient communities thought about resource allocation, family planning, and survival triage during desperate circumstances. Archaeological and anthropological evidence suggests that ancient human communities occasionally faced similarly brutal resource scarcity decisions, though the social and psychological framework surrounding these decisions differed dramatically from purely instinctual animal behavior. Extended family and community support systems meant that ancient human parents facing resource scarcity had considerably more options available compared to animals operating in isolation. Rather than immediately resorting to abandonment or harm, ancient communities could potentially redistribute resources across the broader group, seek assistance from extended family members, or rely on community-wide food sharing arrangements that provided a crucial safety net unavailable to most animal species facing comparable survival pressure. This distinction reveals something important about how ancient human social structure fundamentally changed the calculus surrounding offspring survival compared to the broader animal kingdom. While individual animals often face harsh either-or survival decisions in complete isolation, ancient humans developed increasingly sophisticated cooperative systems specifically designed to distribute survival burden across an entire community, rather than forcing individual parents to make impossibly brutal calculations entirely alone. This cooperative approach likely significantly reduced instances of infanticide within ancient human communities compared to what might occur without this kind of robust social support network. Let's consider something worth appreciating regarding a completely different category of animal offspring killing: behavior related to protecting existing offspring from potential future threats. Certain species will kill weaker or sickly offspring, specifically to prevent that individual from potentially attracting predators toward the entire family group, essentially sacrificing one vulnerable member to protect the survival odds of stronger siblings and the parents themselves. This calculated risk management, while brutal from an emotional perspective, represents another example of evolutionary logic prioritizing overall genetic continuation and group survival over individual preservation. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. Birds demonstrate this particular pattern with surprising frequency, sometimes pushing weaker chicks out of the nest or actively neglecting feeding toward the weakest members of a brood, particularly during years when food availability proves especially limited. This might initially seem cruel, but from a strategic standpoint, it prevents parents from exhausting limited energy and resources attempting to save an offspring unlikely to survive anyway, while ensuring stronger siblings receive adequate nutrition necessary for successful development and eventual independent survival. Take a moment to appreciate one of nature's most unintentionally hilarious survival strategies, because certain fish species have taken offspring management to a level that sounds almost like a bad parenting joke. Some male fish, after fertilizing eggs, will guard them fiercely against predators for days, only to turn around and eat a portion of their own eggs if food becomes scarce or if he senses the batch is somehow compromised. Researchers call this filial cannibalism, which honestly sounds like a fancy academic way of saying dad had a snack he probably shouldn't have. From a strictly caloric standpoint, though, it makes sense. Guarding eggs burns energy, and if the male doesn't eat something, he might not survive long enough to guard the next batch either, so occasionally sacrificing a few eggs today ensures viability for tomorrow's brood. Ancient humans, thankfully, never adopted this particular strategy, though one imagines the campfire conversation if they had. Now, here's a particularly interesting angle worth exploring regarding social species specifically, since group-living animals sometimes display infanticide patterns directly tied to maintaining social hierarchy and group stability rather than purely individual reproductive strategy. Certain primate species, for example, show evidence of dominant females, sometimes targeting offspring born to lower-ranking females within their social group, essentially maintaining hierarchical control over reproductive access and resource allocation within the broader troop structure. This behavior, while unsettling from a human moral perspective, reflects the same underlying evolutionary pressure driving virtually every example we've discussed throughout this exploration. Maximizing individual genetic success, sometimes through direct competition with or elimination of genetic rivals, even when those rivals happen to be members of the same species or social group. Here's a fact that tends to surprise people during casual conversation, mostly because it sounds like something out of a nature-themed horror movie. Certain species of rodents, particularly some mice populations, will completely reabsorb embryos before birth if environmental stress becomes overwhelming enough, essentially canceling a pregnancy internally before it ever reaches the birth stage at all. This phenomenon, occasionally observed under laboratory conditions and suspected in wild populations facing extreme stress, represents perhaps the most efficient version of reproductive triage found anywhere in the animal kingdom. No dramatic confrontation required. Just a quiet, internal biological decision that the timing simply isn't right. Ancient humans, dealing with comparable stress through famine or extreme hardship, obviously couldn't pull off anything quite this efficient, but the underlying biological instinct toward pausing reproduction during desperate circumstances likely echoed through ancient human physiology in its own, less dramatic ways, too. Let's pause and consider something fascinating regarding how ancient human social structure appears to have actively worked against this particular pattern, rather than mirroring it the way certain other primate species do. Unlike hierarchical primate troops, where dominant females sometimes eliminate offspring born to lower-ranking group members, ancient human communities generally developed considerably more egalitarian approaches toward child-rearing and resource distribution. Rather than concentrating reproductive success exclusively among the most dominant or socially powerful community members, ancient human groups appear to have distributed caregiving responsibility and resource access more broadly across the entire community, regardless of individual social standing. This represents a significant evolutionary divergence worth appreciating, since it suggests ancient human survival strategy specifically favored cooperative, broadly distributed reproductive success rather than the more hierarchical, competition-driven reproductive suppression seen in numerous other social species. This cooperative approach likely contributed significantly toward ancient human population growth and long-term survival success, since maximizing the number of successfully raised offspring across an entire community. Rather than concentrating reproductive success purely among dominant individuals, ultimately provided stronger overall genetic diversity and greater total population resilience against environmental pressure or disease. Let's touch on something worth mentioning regarding environmental and seasonal factors that influence infanticide rates across various species, since this connects directly back toward understanding ancient human survival decision-making too. Many species show significantly higher rates of offspring abandonment or active infanticide during particularly harsh seasonal conditions, drought periods, or following unusually poor previous breeding seasons that already strained available resources. This pattern suggests that infanticide across the animal kingdom often functions as a kind of emergency response mechanism, specifically triggered by desperate environmental circumstances rather than representing routine, casual behavior occurring regardless of actual resource availability. Ancient human communities almost certainly faced comparable seasonal and environmental pressure, particularly during harsh winters, extended droughts, or periods following unsuccessful hunting seasons that left food reserves dangerously depleted. However, as previously discussed, the cooperative social structure characteristic of ancient human communities likely provided considerably more flexible response options compared to animals facing similar pressure in isolation. Community-wide resource sharing, extended family support networks, and collective decision-making regarding resource allocation during genuine crisis periods likely reduced the frequency of infanticide within ancient human populations compared to what pure individual survival calculation might otherwise predict. Now let's briefly acknowledge something worth considering regarding the broader ecological purpose infanticide serves across animal populations generally, since understanding this helps contextualize why this behavior persists so consistently across such a wide range of species, despite seeming so viscerally troubling from a human emotional perspective. Population regulation represents a crucial ecological function that infanticide inadvertently serves within many species, helping prevent overpopulation that might otherwise exceed available environmental resources and potentially trigger broader ecological collapse affecting the entire population rather than just individual family units. While individual animals certainly aren't consciously thinking about ecological balance when engaging in this behavior, the cumulative effect across an entire population helps maintain a rough equilibrium between population size and available environmental resources. This ecological regulation function becomes particularly relevant when considering how ancient human population growth eventually began outpacing what purely animal-style population regulation mechanisms could reasonably manage. As ancient human cooperative strategies became increasingly effective at supporting offspring survival, even during periods of resource scarcity that might trigger infanticide in comparable animal species, human population growth likely began requiring different, more sophisticated approaches toward long-term resource management and environmental sustainability, approaches that eventually contributed toward the development of increasingly complex social structures and, eventually, agricultural practices that provided more reliable, controllable food production compared to purely hunting and gathering-based subsistence. Finally, let's circle back toward something worth appreciating regarding ancient human innovation in direct response toward the harsh survival calculations we've spent this entire exploration discussing. Faced with the same fundamental biological pressures driving infanticide across countless other species, ancient humans instead invested heavily in developing social technology, essentially inventing cooperation, resource sharing, and community support as evolutionary tools specifically designed to sidestep the brutal, either-or calculations facing so many other species. This wasn't a conscious, deliberate decision made in a single moment. It developed gradually across countless generations, as communities that supported struggling mothers and shared resources during difficult periods consistently outperformed and outlasted communities that didn't. In a strange way, every act of ancient human kindness toward a struggling parent or vulnerable child represented a radical evolutionary experiment, one that ultimately proved remarkably successful compared to the more brutal reproductive strategies still playing out across so much of the natural world today. Let's wrap up this exploration by considering something important regarding how understanding animal infanticide actually helps illuminate just how remarkable ancient human cooperative behavior truly was within the broader context of animal reproductive strategy, where countless species across the animal kingdom developed infanticide as a logical, if brutal, response toward genetic competition, resource scarcity, or social hierarchy maintenance. Ancient humans developed an entirely different evolutionary strategy centered around cooperation, resource sharing, and community-wide support specifically designed to maximize offspring survival even during difficult environmental circumstances. This doesn't mean ancient human communities never faced impossibly difficult survival decisions, since harsh reality certainly sometimes forced communities toward painful choices during extreme crisis periods. However, the fundamental difference lies in approach and available options, where most animal species face these decisions through isolated individual calculation driven purely by instinctual biological programming. Ancient humans developed increasingly sophisticated social and cooperative frameworks specifically designed to distribute survival burden across an entire community, providing considerably more flexibility and support compared to species forced to navigate identical pressures entirely alone. So what does all of this ultimately reveal about the fundamental difference between typical animal reproductive strategy and the cooperative approach ancient humans eventually developed? It reveals that while nature often operates according to brutally logical, if emotionally troubling, evolutionary calculations regarding offspring survival and genetic competition, ancient humans managed to develop something different through increasingly sophisticated social cooperation. Rather than purely individual genetic competition driving reproductive strategy, ancient human communities increasingly prioritized collective survival and cooperative resource distribution, fundamentally altering the evolutionary calculus that drives infanticide behavior across so much of the broader animal kingdom. Next time you're watching a nature documentary and witness behavior that seems shockingly cruel from a human emotional perspective, remember that you're observing millions of years of evolutionary programming operating according to logic that, while uncomfortable, actually makes considerable biological sense once properly understood. And the next time you consider just how much support, cooperation, and community assistance surrounds modern childbirth and parenting, even compared to relatively recent historical periods, remember that this cooperative approach traces back across countless generations of ancient humans who somehow figured out that working together toward collective offspring survival ultimately proved more successful than the isolated, purely competitive reproductive strategies that continue driving so much of the animal kingdom even today.